inviting me to this and inviting Hamina to this. We're really excited to present here. And I've got a number of different things that we'll talk about today. I think what we'll probably focus on is kind of the main thing that we do here at Hamina, which is wireless network design. That's kind of our gig here. So just in case you're not familiar with me, my name is Joel, and I do a bunch of different things at Hamina. I do like a little bit of technical marketing, engineering. I do a little bit of product management and some sales engineering. Really, it's all over the place. We all do a bunch of different things here at Hamina. So the thing that we make is we make a wireless network design tool. That's our gig. It's a tool that runs out of a web browser, runs in the cloud. And what I love about being a vendor that makes a tool, a very visual tool like this, is it's perfect for teaching people how to do things. So when I tend to give these presentations or give talks, I always just show the thing that we make because it's a great way to illustrate points. So I figured this could be kind of a dual purpose webinar where we can talk about not just how to do wireless network design, but I can also kind of show you what we do and how our tool works at the same time. So I hope that's okay with everybody. Hopefully that's good with everyone. So yeah, yeah, I think with that, yeah, let's go ahead and jump in. And maybe if the Mobility Brazil people could remind me, how much time do I have? I don't actually remember off the top of my head how much time I've got to present. Sorry, I didn't ask a moment ago.
So no problem. So you got 45 minutes, but since we started a little bit earlier, you probably have like 50 minutes. So you're
nice.
Should be good to go.
All right, perfect, cool. Well, let's not waste any more time then. I'll jump right in and start talking about stuff. So yeah, whenever you're doing wireless network design, there's always kind of two sides to doing a design. So the first side is to create what's called a predictive model or a simulation of the network. So that's actually what you're looking at right now. This is a simulation of a wireless network. It's not based on real data, but it's based on sort of like an educated guess. So we're basically sort of making an educated guess at what the wireless network is going to be. So that's the first side of it. The second side of the network design process is to do a site survey. So here in this project, I've actually got both. And so here you can see that I've got a simulation. So for example, I can grab an access point and move it around. And a tool like this is going to calculate what the coverage is going to look like from a tool like this. And it's going to make basically those educated guesses on what the network design is going to look like. And we'll get fully into this. We're going to dive into this and you'll see exactly how all of this works. So that's kind of the first side of it. The second side of a tool like this, and this is something that we're working on right now. We actually don't have this for sale yet. So you're seeing something that we don't quite sell yet, but it'll be available soon, is you can go take a site survey and build a map of what the coverage is going to, what the coverage actually looks like in the real world. So there's sort of there's sort of multiple steps to doing a network design like this. So first off, the very first thing that you're going to do is you're going to gather requirements. And so this is when you're going to find out a bunch of important things from the customer, like where do we want Wi-Fi? Where do we not want Wi-Fi? Those are really, really important questions to ask. And so we're going to use those to inform what the wireless network is going to look like. And then the next thing that we're going to do is we're going to create the design. And so sometimes we'll call this building a predictive model. And so we're basically making a simulation of the wireless network. And so we gather our requirements and then we do our design or our predictive model. So then the next part is, of course, we need to deploy the network. So that's when we'll actually go and pull the cables and hang up the APs on the ceiling and do all that work. And then the final step, typically the final step, is then we will perform a site survey. And kind of the full name for this would be a post-installation site survey. And so we're going in there and we're making sure after our installation, we're making sure that the network actually meets the requirements that we set for it. Remember early on, we decided on the requirements, and then we'll go in and actually see whether we met those requirements that we set for the network or not. So let's go through that process. I'll just show you what it looks like to do a wireless network design. So let's start out by bringing in a floor plan. So I'm just going to do like a boring office build. We'll call it boring office building. So we're going to go with like the easiest, most simplest thing ever. And of course, let's do that. Let's set our country to Brazil, and then we'll leave the environment set to just open and then hit save. And now we need to bring in a,
yeah, go ahead. To you for 5 seconds.
Sure.
It's just a kind of request here. Can you try to speak a little bit slowly.
Yeah, yeah, absolutely. I get that feedback pretty often. I suppose I get excited about this
If
stuff,
that's
and I
okay with
tend
you.
to,
Thank you.
yeah,
Appreciate.
it's certainly okay. Thank you so much for bringing that up. I'm really glad you said something. So yeah, I'll speak a little bit slower. So then the next thing that we need to do is we need to bring in a floor plan. We need to give us a map to work with. And this could be any common image type. This could be a JPEG, a PNG, a PDF, or even something complicated like a CAD file. So we'll bring in our floor plan, and that's going to upload to Hamina. Then the next thing that we need to do is we'll need to set the scale for our floor plan. Now, the scale is really important because we use that to calculate things like free space path loss, loss over distances that happens with RF. So we'll set our scale really quick. I happen to know that this building is 60 meters from side to side. So we'll click here, and then we'll move over here to the other side, and we'll click again, and we'll type in 60 and hit set, and there we go. So now the next thing that we need to do is we need to draw in some walls. Now to do that, I'm going to place an access point so you can see what the effects of drawing walls are. Let's start with just a Juniper. Maybe we'll use a Juniper AP43. So we'll place an AP43 on the map. And right now you can see that since there's no walls, we just have basically a circular coverage pattern around our access point. So now we'll click on Draw Walls, and I'll select a material type, and we'll start drawing in the different types of walls that we think are in this building. Now you have to guess a little bit when you do this work. Typically, I like to go on site, and I like to look at what kind of knock on some walls and try to figure out what the walls are made of. So I'm going to say that around this stairwell, this is probably concrete. So I'll select the concrete profile, and then we'll just go draw some walls. We'll go left click, left click, left click, and just start filling in what we think those walls are made of. Now let's do some drywall around these rooms. And so I'll switch over to a drywall profile, and we'll just do the same thing. Left click, left click, left click, and just start drawing in all these different walls. Now you can see that a building like this only takes a few minutes to draw in. Drawing in a building does not take very long. This is probably going to take me about 5 minutes to draw this floor. Not a big deal. But now we can select our access point and move it around, and you can see how those walls are causing attenuation. They're attenuating that signal, and they attenuate that signal by a certain amount of dBs or decibels. So if we click on one of those walls, you can see that our drywall profile, I'll circle it here so it's easy to see, we can see that the attenuation for drywall in our design is 3 dB, and attenuation for the concrete is 15 dB. This is the most important number when we're doing a predictive model, is what is the attenuation of each wall. And you can change this. So for example, we could go click on a wall on the add or modify button here. And then we could go say, well, let's go change our drywall from 3 dB to 6 dB. So we just doubled the attenuation. And then we click save, and notice how much the coverage changed. So remember, this is a simulation, and whatever numbers we put in here, if we can make them match the real world as closely as possible, they're going to make the model match the real world as much as possible. So be sure to change these and adapt these to your specific building and your specific design that you're doing. Okay, so we did manual drawing, but let's have Hamina draw everything in for us automatically. So to do that, I'm going to go to the Draw Walls tool and go to Auto Draw Walls, and this works for CAD files and PDFs. It doesn't work for every CAD file or PDF, but it works for most of them. So now we'll go find the different layers of the CAD file or the PDF, and we'll tell Hamina what these walls are, what these layers are made of. So I can click on the wall layer, and we'll assign drywall to that layer. And then we'll click on all of the concrete columns and say that those are made of concrete. Then we'll click on the windows and say that those are all windows. Pretty easy. And then the doors are solid wood. And then we'll import those. And now Hamina is going to go through and draw those in automatically. And by the way, this is something that several different tools out there do. I know that Ekahau does this as well. So be sure to try it and see if your design tool supports automatically drawing in the walls. Sometimes it works great. Sometimes it doesn't. It kind of depends on the file. Sometimes I use it. Sometimes I don't, even in Hamina. All right, so now we have our walls in here. And so now let's place some access points. So earlier I used a Juniper. Let's use something else. Maybe something, I'm looking down the list here. Let's use Fortinet. So let's go with a Fortinet, and I'll use maybe like a U43F. So we'll click on that access point, and you can see that the height of the access point is set to 2.5 meters. And you can see the transmit power is 6 dBm in 2.4 gigahertz and 10 dBm in 5 gigahertz. So now we can simply click to place the access points and design for coverage. So right now I am just looking to see and make sure that everything on the map is green. And the reason I'm looking for everything to be green is I am looking to make sure that I have negative 65 dBm of coverage everywhere. So everywhere that's green means that I have negative 65 dBm or better. You can change this requirement. If you decide that negative 67 dBm is going to be enough coverage for your network, then you could simply change that. And notice how the heat map just changed to show better coverage everywhere. In fact, we could take it down even more. We could say that our requirement is negative 70 dBm. And so now you can see the coverage looks even better. The coverage didn't change. We just changed the threshold to make it to make it show whether we're meeting our requirement or not. So typically, yeah, go ahead.
Sorry to interrupt you. I'd like to know if you have some possibility to simulate a private 5G access points that possible to do that in Hamina?
Yeah, absolutely.
Can you show
absolutely
after this example with Wi-Fi with a private 5G example? Because we have some projects involving this technology.
Yeah, absolutely. And by the way, if there's any questions, please feel free to interrupt me to answer those. I think questions make for a much more fun webinar or presentation. So anytime, feel free. Okay, so let's switch over to private cellular. So I'm just going to switch the heat map over to 4G, 5G. And here we're looking at primary RSRP. And let's go choose a 4G, 5G access point. In this case, I'll use a Salona indoor AP22. So we'll place an AP22, and now instead of looking at Wi-Fi, we're looking at coverage for private cellular in the same design. So maybe we place one here, maybe one here, perhaps one here, and then one here, and maybe one more in this corner. So with just a handful of private cellular access points, we've covered this floor. And it's nice to be able to see the difference between one private cellular access point and one Wi-Fi access point. So there's our coverage from one private cellular. Let's switch over to Wi-Fi and just click on one. There's coverage from one Wi-Fi access point in the 5 gigahertz band. It's nice to be able to see those comparisons. And hey, it looks like joining us from Spain is Jussi Kiviniemi. Hey, Jussi.
Hey, Joel. How are you, man?
I'm pretty good. I didn't know you were here.
I didn't know I was here either. sorry for jumping late. I was just gonna say, like, well done on showing those differences, and like what we're showing now is pretty conservative limits for private cellular, right? So some private cellular networks could be, tuned down quite a bit. Lower RSSI values as well, but what we're showing by default is quite strict limits, right?
That's a really good point. A moment ago, we were talking about requirements and how you can set what those requirements are. So remember, on the Wi-Fi side, our cutoff was negative 65 dBm. Here on the private cellular side, we've got it set to negative 80 dBm. This is just a default in Hamina. You can change this to be whatever you want. So if you wanted this to be maybe negative 100 dBm, we could absolutely adjust these values. So I could say red is going to be 120, yellow is going to be 110, and green is going to be 100. And now if we click on just one of those APs, you can see that makes a really big difference for coverage. So be sure to set those requirements to meet whatever your requirements for the network are. You can talk to your private cellular vendor, you could talk to your client vendor and find out what the best numbers to use are depending on the equipment that we're using. Great. So let's switch back over to Wi-Fi. And the next thing I want to do is I would like to define the requirements for this network a little bit more. Earlier, we looked at the requirement for our primary coverage, so our coverage from the loudest access point. We might also want to design for secondary coverage. So secondary coverage shows us anywhere that we have 2 or more access points meeting a certain signal strength. In this case, our requirement for 2 or more access points is -67 dBm. So anywhere that's green ensures that we've got 2 or more access points above -67. Let's set it to -70. And you can see the difference now. Everywhere that's green is 2 access points at -70 dBm or better. Maybe that's our requirement for our network. So let's use that. Let's fix some of the secondary coverage issues that we have here. So I'm going to say, let's move our Fortinet up here, and let's place another one down here. So there we go. We filled that area in a little bit better. I'm going to put one more access point right here, and everything else looks pretty good. But one problem that I have is I'm showing coverage outside of the building, and it makes it look worse than it really is. So to better set our requirements, I'm going to use a scope zone. So a scope zone tells us where we want Wi-Fi and where we don't care. And I'm going to draw in the scope zone, kind of like I draw in walls. I'm just going to go around and go left click, left click, left click, and keep doing that until I've traced in the entire floor. You can also click and drag to make squares. That's fine too. It's a lot faster. It just depends on how you want to mark the floor. So we'll go around the outside here, and I'm going to keep the stairwells out of our design, and then I'll right click to stop. And now we've defined the scope of the project. We might also decide that we want to take some rooms out of scope, like maybe the bathroom is not in scope. So we can simply click and drag there, and now that is taken out of scope for the project and it's not going to be included. Now, down in the corner is our legend, and this shows us what all of our cutoffs are for our different signal strength colors. If we hover the mouse over that legend, we show you what percentage of the floor plan is meeting the requirement. And as you can see, 95% of our floor plan meets our requirement for -70 dBm of secondary coverage or better. So I will often kind of set a bar here. I'll decide that I'm going to meet a certain requirement at a certain signal strength. It might look something like this. I might say, let's go for a color that we can see easily. Let's do blue. I might say for secondary coverage, oh, you can't see that very well at all. Let me fix that really quick. Let's do that right here. So I might say for secondary coverage is going to be -70 dBm or better on at least 90% of the floor plan. That's how I will write a requirement. So that way, as I'm doing the design, I don't have to worry about getting every single corner, every single closet, and every single bit of the floor plan green, which is ultimately going to save us a lot of money. It's going to save us access points, and it's going to save us cable runs as we're doing our network design. So I think this looks pretty good. So now let's do another floor. Let's go do the next floor up. So to do that, I'm going to open up the multi-floor tool, and I've got multiple maps that were part of this PDF file that I imported earlier. So floor 1, floor 2, and floor 4. And I'm going to rename these to make them easier to keep track of. So we'll say floor 0, and then we'll say floor 1, and then we'll say floor 2. And we can change the height of each floor, and we can also change how much attenuation there is between each floor as well. Now we need to align the floors. So I have floor 0 selected right now. You can see it has a black dot next to it, and it's the black map on the floor plan. And then we have floor 1, which is colored in yellow. So we can simply drag those two floors over each other, and now they line up. And now we'll grab floor 2, and we'll drag it over here and line it up. And there it is. Now we have all 3 of our floors aligned. So now we can switch to the next floor, and we can draw in all of our walls. We'll turn the heat map off, and we'll say that this is all glass. This is all a heavy drywall, and these are all doors, and import those. And then we'll go up to the floor on top, so up to floor 2, and we'll do the same thing here. I'll select all of the windows, and then I'll select all the drywall, and then I'll select all the doors, and then we'll hit import. And now we have all of our walls on this floor as well. But one thing that we need to do is we need to deal with this void in the floor right here. So we have this empty space. There's a large atrium here, and that's empty space. So I'm going to use the floor holes tool to draw a hole in the floor right there. And I'm going to place just one access point right here on the edge. So there's our access point. And now let's go downstairs. So we'll go down to floor 1. And because of the empty space, we can see how the RF propagates from the top floor all the way down here to the bottom floor. And so you can do these designs with 3 dimensions in mind. And that's really important because since Wi-Fi goes through floors or bleeds through floors to some degree, we are going to see interference from floor to floor. So, for example, if we place our access points here, so here's all of our access points on floor 2. If we go look at the interference map, this is going to show us anywhere that we have multiple access points on the same channel. Whenever 2 access points are on the same channel, they have to take turns talking. They have to compete for time to talk. And all the clients that are associated to those access points have to do the same thing. So we want to try to keep access points off the same channel wherever possible. While you do a design in Hamina, then it automatically redoes a channel plan for you. So you can see that here we've got 2 access points. This access point right here is on channel 1 in the 2.4 gigahertz band and channel 52 in the 5 gigahertz band. Whereas on this access point, we've automatically turned off the 2.4 gigahertz radio because there aren't enough channels available to use every radio. And we've put this access point radio on channel 108. So while you're doing the design, whenever you change the location of any access point or place a wall or do anything like that, Hamina will rerun the channel plan to try to avoid that interference or keep access points on separate channels. So we can change this a little bit. If we click on an access point and go to the channel settings, we can change what channels are available to the channel planner, and we can also change what channel width Hamina is using. So for example, let's say you have a client device that doesn't support any of these channels in Uni 2C. And by the way, notice that we've taken out all the channels that aren't available in Brazil already. We can remove all of those access point channels, all those channels that access points might be on, and now it reruns the channel planner again with those constraints in place, and you can see that the interference is even worse. So we can improve this by going to a narrower channel width. Right now, we're using a 40 megahertz wide channel, so we could back this down to a 20 megahertz wide channel, and Hamina will rerun the channel planner again, and it'll try to reduce the co-channel interference with those new settings that we've applied. So that's how you can do some channel planning in Hamina to make sure that it's going to not interfere with itself. Let's do another design. Let's do something in a little bit more complex of an environment, maybe like a warehouse. So I'm going to set the country to Brazil again, and we'll set the environment to a warehouse, and we'll hit save. And then we'll import another floor plan. This time, it's going to be just a standard JPEG image. Just a normal.
Just one quick question before
Yeah.
you move ahead. So it's very interesting, this capability of 3D, analysis of the planning. Can you do this 3D analysis with any of the parameters that you have simulated? For instance,
Absolutely.
Roaming. Roaming is another issue that we face when we have this kind of signal leaking in open spaces. So can the tool also helps identify the impact of that in roaming capabilities?
Absolutely. Absolutely. So back in this office building design that we've created, there is a tool in Hamina called the client view. And with the client view, you can select from a list of common client devices that we know the roaming behavior for. So for example, we have the iPhone in here. We were able to look at Apple's documentation, and Apple was able to tell us exactly when an iPhone roams and how it decides which AP to roam to. In the case of the Android phone, we looked at the Android open source project and so on. So we can take the iPhone and click and drag to move it around on our network, and we will predict when the iPhone is going to roam and which access point the iPhone is going to roam to. So you can see here that it's doing a pretty good job of picking the best access point to roam to. It's working fairly well. But if we move all the access points out into the hallway, so let's do that really quick. I'm just going to move all the APs in the hallway. And now you can see that we still have good coverage everywhere. So we don't have any coverage problems. We just moved where the APs are. Let's hide the access point channels and numbers so we can see a little bit better. And let's also turn off our heat map so we can see even better. And we'll zoom in a little bit. So we'll take the client view and we'll just drag it through the environment, and you can see now that it sticks. It is now stuck to the access point at the end of the hallway, and it's only when we get around the corner right there that the client finally decides to roam. So let's do it again. We can walk through here. It'll now associate to that access point, and let's see which one it associates to now. So it actually decided to go to this one here, which was a very good choice, and then it jumped back. So it's funny to see how the clients will decide which access point it's going to roam to. And remember that this is based on your access point location, transmit power settings, and the real known roaming behavior of these client devices. I hope that answers the question.
Yeah, no, that's a super cool feature. My question was a little bit more specific. So the 3D effect also is taken into consideration for this capability, or in this case, you're using just this floor information for that?
Correct. Yeah, today in Hamina, we only look at the APs on the current floor, but we were actually discussing this internally at Hamina literally last night, and we are going to expand this to include roaming to APs that are on other floors really soon.
Okay, great. Thank you.
Yeah, you're welcome. All right, so let's switch back over and do another 3D design. So let's go start another warehouse project. We'll just make a new one. So we'll say warehouse. This is in Brazil. And we'll say that the environment type is a warehouse and hit save. Now I'll bring in another floor plan. This time it's just a JPEG, just a standard normal old JPEG. And then of course we need to set the scale. And one thing I recommend doing is always using the longest thing that you can to set the scale with. In this case, I know that this building is 20 meters from top to bottom. So there's 20 meters. And now we'll draw in our walls. So this one's pretty simple. We'll just do some walls around the outside in concrete. So we'll just go click, 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 click. Whoops, I didn't do the last part there. Let's try that again. And then we'll do our heavy drywall around the inside. I won't worry about all the details just for the sake of time. And then we'll do this small break area.
Real quick.
Yes.
I'm going to speak a little bit in Portuguese here, so give me just like 30 seconds.
Go ahead.
Pessoal, se vocês tiverem alguma pergunta, só levanta a mão, a gente vai levar o microfone para vocês aí, tá?
Então, por favor, só faz assim que aí a gente leva o microfone para vocês, beleza? E se tem algum problema na parte de tradução, a gente tenta ajudar, tá? Mas tem problemas, o Joe tá aí. Então, só levanta a mão aí pra gente.
Até um ponto, pessoal, não sei se vocês viram aqui agora há pouco, o Joe mostrou uma funcionalidade bem interessante, é você simular o roaming do equipamento direto na predição. Então ele pegou um iPhone aqui, qual que é o threshold do iPhone para fazer um roaming? Aí ele foi movimentando o iPhone dentro da planta preditiva e foi mostrando, olha, ele vai sair desse access point para esse outro. Aí ele mudou o perfil, o laptop, como se comportaria. Então isso é bem interessante porque você consegue, na planta mesmo, já ter essa visibilidade, ter esse comportamento de como seria essa transição. Então é muito comum, às vezes a gente está num projeto, poxa, por que não fez o roaming? Deixa eu fazer uma simulação para ver o que aconteceria de fato, tá? Mais para vocês terem essa visão também que ele está demonstrando aqui, que dá para ter essa ideia. Thank you, Joe.
All right, Joe. Thank you. Back to you.
Sounds good. Thanks. So let's draw in some other objects here. Now, up until now, we've just been using walls. Let's place another access point to illustrate this really quick. Let's go with a ruckus this time. Maybe a new, let's go with something from the R series, like the R850. So we'll place an R850 in here. Now, looking at the ruckus, you can see the attenuation from the concrete walls. And remember that our attenuation was set to 15 dB. So down here in the corner, there's an inspector that we can use to see how much signal drop there is from side to side on this wall. As I move my mouse, you can see that you can see the little indicator of what my mouse over is happening right now. Basically, how much signal there is directly underneath my mouse pointer. And if we look from side to side on this wall, we're going to see about a 15 dB drop. So we go from negative 50 dBm to negative 65 dBm. And that's how wall attenuation works in tools like Hamina. So then there's another type of attenuation that we can place. We can create attenuating objects, and these work a little bit differently. So if we place an attenuating object, in this case, I'm going to use a warehouse shelf. This loses 8 dB per meter. So on a per meter basis, we are losing 8 dB for every meter that the RF has to travel through that material. So when we place these shelves, they're not going to just attenuate the signal one time. They're going to attenuate it at the further, more and more, the further the RF has to go through that object. So I'm just going to go through and draw in some shelves really quick. Just drawing in some shelves. And then if we go to the 3D view, you can see that those shelves have a height value to them as well. So let's go back and create some more shelves, but I want to do a shorter type of shelf down here. So I'm going to create a new profile. We're going to call this warehouse shelf short. And I'm going to make the height be 2.5 meters, and I'm going to make it purple so it stands out. And then we'll draw in the shorter shelves right here. So we'll just draw those in really quick. And then once I have the shelves done, let's switch back to the 3D view, and you can see now that they're shorter. So let's place our access point at maybe 4 meters, so just a little bit higher. And if we start moving that around, you can see the attenuation from the short shelves behaves very differently from the attenuation from the tall shelves. Like if we place this access point inside the aisle, we're only really covering that aisle, whereas if we place it above these short shelves, it covers those just fine. So in a warehouse environment like this, I like to use a directional antenna to really get the signal down to where we need it. So let's do that really quick. I'm going to go for maybe like a Cisco, and let's go use the new 9166D1. So this has an integrated directional antenna. And you can see from the patterns here that this has quite a bit of directionality. It has about 6 dB of gain. And the parts that are red is where the majority of the signal is going to go. So then we could say, well, the ceiling in here is 9 meters. So let's put the AP 9 meters high and put it over here up against a wall. And then maybe we want to give it some down tilt. Let's point it down slightly. So we'll say 45 degrees of down tilt. And now you can see how that access point, even though it's way up on the ceiling, is still covering the floor fairly well. If we switch this to an omnidirectional antenna, like maybe we go for just a 9164, you can see that it still covers on the ground fairly well, but it's a little bit weaker on the ground compared to where the D1 was. So we'll go back to that D1. Once again, give it that 45 degrees of down tilt, put it towards the wall. And then this is when I like to go around and simply paint the coverage around to wherever we need it, such as down the aisles, maybe down from the other end of each aisle, and so on. So that's how I like to use directional antennas in places like warehouses, auditoriums, and anywhere else that I need to get signal strength to a specific location on the floor. Okay, so we've talked quite a bit about how to do Wi-Fi design. I think another thing that's good to talk about for just a couple of minutes is how to do how to account for this on the wired side of the network. So the two things, really three things that we need to worry about when it comes to the wired side is we need to worry about how many ports we have available and also what the PoE or power over Ethernet requirements of our access points are. In the case of the Fortinet U43Fs, that's a bit of a tongue twister, we need 24.5 watts of PoE per access point. So to plan for that, I'm going to go place a switch in this building. So let's go place a switch in this room right next to the elevator. And then for this switch, let's say that it's just a 24-port switch and that it has 300 watts of PoE. To meet the PoE requirements on this floor, we're about 18 watts short. So we're not going to meet our requirement for that. So to make things easy, I think I'm just going to place another switch. So we'll go drop another switch. There's another closet right here. And now we have switch 1 and switch 2. And you can see that on this first switch, we're using about 200 watts of all of our PoE capacity. And we're under 100 meters for each cable run, so no problems there. And we're looking at about 400 meters to do the cabling on this floor. So you can use a tool like this to make sure that everything is within specification and that all your cabling and power requirements are going to be met. And if there's already some things in the building that you need to power as well, like maybe you have some desk phones, for example, you can account for those as well. It's typically, in some cases, you're going to be planning for both the wireless access and also maybe for some of the wired devices that need to use the same switches. So here you can see that I placed a bunch of desk phones. These all pull about 13 watts. And if we click on that switch, you can see that now we're 38 watts short. So we really need to boost this up to a 48-port switch, maybe that has 700 watts of PoE, and now we are meeting our requirement. So let's say that you have done your design, and now you're ready to present this to your customer. There's a couple of things in Hamina that might be useful. First off is the bill of materials. So this shows us all of the things that are going to be required to build out this network, from the APs, any antennas that you use, your access points, and your switches. And then from here, you can go create a report. So we'll call this a boring office building report. And then from here, this is where I'm going to store all the requirements that I took. For example, under the project notes, this is where I'm going to keep any notes about the requirements that we're going to meet. Like maybe I would say primary coverage needs to be -65 dBm on 95% of the floor or more, and so on and so forth. I might also make a list of supported clients. I might decide which clients are going to be supported. Like maybe we have 50 Lenovo Carbon X1 laptops. Maybe we have 100 iPhones, and basically just make notes about anything that we would need to keep track of in the project, anything that I would want to be able to hand the customer when I'm done. One of the main reasons I like to keep everything inside a project file, and this is true for any design tool, whether it's Hamina, whether it's Tamagraph, whether it's Ekahau, is I want to have a single source of truth. one place that contains all the requirements and one place for all of the documentation. And so that if several years from now, if a customer comes back to me or a manager comes back to me and says, hey, the Wi-Fi isn't working, we can say, well, let's go look at the documentation and see what we designed the network to do. And then that might give us some room to have a conversation about what's going to have to change, how we might have to do a network redesign. This is typically going to be a couple of pages worth of content here. So then
Joel?
from there, yeah, go ahead.
Sorry to interrupt you. You have more 7 minutes, right?
Yeah.
And I'd like to ask you about if you have some example about a stadium, for example, if you can, have some example that we can see a 3D of a stadium, because we have some projects in Brazil related to this kind of environments, and that would be nice to see how it's going to be a stadium in a 3D view. And another question that we have is about the post-site survey. As you know, it's very important to understand more about it as well. Thank you.
Sure. Absolutely. You said I have about 7 minutes left? That should be enough time. All right. So yeah, real quick.
5 minutes for questions, but you can go ahead.
No 5 minutes for questions?
Yes.
Great. Thank you. All right. So here is an example of a stadium environment. And this background map is just a JPEG. No special CAD file or anything like that here. Basically, you can define areas that define either a sloped floor or a raised floor. So in the case of this seating area at this hockey arena, you can see that I have created a sloped floor section and also a raised floor section here as well. I'll show you what that looks like to build out. So we can go use the sloped floors tool, and we can define the lower height of that sloped floor and the upper height. And so then we could say this is the lower side of that seating area, and then this is the upper side of it. So let's do that again. So let's do another lower side, and then another upper side, and a lower side, and an upper side right here. And we can just keep doing that until we have built out all of our stadium area. We'll leave a little gap right there just for fun. So if we go look at that again in 3D, you can see there's all of our sloped areas. And I've also done a raised area around the edge here that you draw in the same way. Let's do a higher section right here. So for this section, we'll do our lower edge here and our upper edge right. Whoops, let's try again. I had the wrong tool selected. We're going to do sloped floor. Let's draw that here. Draw the upper edge here. And then I'm going to define some heights here. I'm going to say that this starts at 5.5 meters and ends at 9 meters. So now if we look at that in 3D, you can see that section there. So now there's a couple of different ways that we could place access points to do a design. Let's go back to our Cisco D1 just because it's right here. It's going to be easy to use. We could place that in our environment like this and say, well, let's pick it up off the ground. Let's say that it's 10 meters high, and let's give it some down tilt, maybe 45 degrees of down tilt. So now you can see how it's covering down there, all the way down there to our stands. We could also place access points inside the seating here, in where the crowd is sitting. Where it's yellow, that's where a crowd is. So let's just go pick an access point. We'll place it here, and let's bring it down into the crowd. So maybe at 0.5 meters, like for example, on the handrails. So now we've got our access point there, and you can see how when it's in the middle of the crowd, it has a lot of attenuation because of the crowd. But as soon as we bring it out onto the ice or onto the field, then you can see how it propagates all over the place. But then when the crowd shows up, it confines it like that, which is great for co-channel interference. That helps us out a lot. Okay, let's take a look at the site survey product that we're coming up with really soon. I'll just show it to you really quick. It only takes a few minutes to demonstrate. So first, I will start out by sharing my iPhone with my laptop. And then to do this, we're going to use our upcoming site survey device, which is called the Osseum Nomad. So that's this device right here. It has a USB-C port for charging here, and another USB-C port for plugging into your iPhone, iPad, or MacBook. So hopefully you can see my screen, my iPhone screen. So we'll start up the Hamina on-site app, and then I'll go ahead and connect the Osseum Nomad to the iPhone. And the Osmium Nomad has Wi-Fi adapters built in, specifically for 6 gigahertz Wi-Fi adapters. And we can use that to perform a site survey. So we'll connect up the Nomad really quick. We'll give it just a second to get connected. Hopefully it just takes a moment. So there it is, connecting. Now it's connected. And now we'll go find our project that we would have set up in Hamina Network Planner. So I'll use the Hamina office here. And then we'll zoom into a room that we want to survey. And then we can go walk around the edges of the room. So I'll tap on the map to say that I'm walking here. Tap on the map here, walk to the other corner of the room and tap on the map again. And just keep doing that until we have walked all over our floor plan and gathered all the data that we need. We can also take notes and things like that. You know, for example, we could add a note right here. So here's a note. And upload that to our project. And there we go. Now we can say that we are done with our site survey. So then once we're done with the site survey, now we can go back to Hamina and we can take a look at those survey results. So we'll go find our project really quick here. And we'll switch over. Remember earlier we did the predictive model here. So we didn't actually do this one, but you remember what that looks like. So this is our predictive model. We'll switch over to our survey, and then Hamina is going to bring in the real world measurements that we took out in the field, and we can use this to make sure that our network is actually meeting the requirements that we set for it. So here we can actually see that we're not meeting our network requirements hardly at all. We've got all kinds of places in this building that we are not serving Wi-Fi, that we're not meeting our primary coverage requirement for our network. And so this is the last step in the process, is to create this post-installation validation survey and make sure that we actually are achieving the goals that we set out to meet. So I think with that, we can take some questions.
Awesome. Thank you, Joe. Pessoal, tem alguma pergunta?
Eu tenho uma
Vocês
aqui.
querem? Pode falar aí, Yuri.
Tá bom. Hey, Joe. I was checking your screen. There's 3 options. So you have your device, you have WLAN-PI, and another thing. Can you go back there and show me again?
Yeah,
I'm curious about
absolutely.
that.
I think I know which one you saw. The one that just said Hamina. So that's actually like a fake data source since we're still developing it. Yeah, it's just just in case we don't have a Nomad to do a live demo with. Yeah, that's all that's for.
Okay, and talk about the Nomad. Did it have a spectrum analyzer as well, or is just a wireless device?
Great question. So the Nomad itself has the 4 6 gigahertz Wi-Fi adapters built in, 2.4, 5, 6 gigahertz. They all do that. And then it also has a USB type A port. So you can see it right there. Yep. You can plug a spectrum analyzer into that. So we're planning on supporting the Osmium Wi-Pri Clarity and also the MetaGeek Wi-Spy DBX. So if you have a DBX, you can plug that in and use that to add spectrum to it.
And that's going to be native, right? To just plug in, play.
Just plug and play. Plug it in, it shows up. You don't have to do any configuration or anything like that.
All right, thank you.
Thank you.
We have a question in the chat. How do you deal with high density of staging projects?
Yeah, that's a really good question. And I see that question there from Diego. Thank you for the question, Diego. Let's go back and look at our hockey arena really quick. I think I have another hockey arena that's maybe not. And there it is. All right. So here's a hockey arena that we've done a little bit of design for in sort of a high density design. And you can see here that I used access points that have a very narrow beam width. So in this case, I'm using the Extreme 560H with the beam 30 setting. And you can see that this is a pretty narrow beam. I really like narrow beams like this for high density deployments because we can break up our coverage cells and keep them as small as possible. So then here, we're showing that we're covering about 4 areas at once, 4 seating areas per access point. So let's see how many clients might be in one of those areas. So to simulate this, I'm going to draw a capacity zone. So basically with the capacity zone, we could say, well, in this area, there's going to be 50 iPhones and let's say 50 Android phones. And we could simply draw in an area like that. Let's draw in another one. So we'll just draw in another area like that. And now Hamina is going to use that roaming calculation that we showed you earlier. It's going to use that to figure out which access points are going to get all the clients. And in this case, you can see that access point number 2 right here, there's 31 clients on the 2.4 gigahertz radio and 123 clients on the 5 gigahertz radio. Is this going to meet our requirements? No, no way. There's no way that that access point is going to be able to handle that load. And so we need to break that up. Maybe we can get away with adding a few more access points. And since we're looking at how the clients are going to decide to roam, we're going to be able to figure out approximately how many clients are going to end up on each access point. And here you can see that we're down to 70 on this radio, we're down to 48 on this radio, and there's only 40 on this radio here. Of course, we've only defined these 2 areas. We need to define more, but you can use this to make sure that you're not overloading an access point radio, or more importantly, not overloading a channel that an access point is on.
Awesome. Thank you, Joe.
Absolutely.
Mais alguma pergunta, pessoal? All right. Well, I think that's it, Joe. Once again, it's not your first time here at the Mobility Brazil conference. Thank you so much for taking the time and doing the presentation for us. I appreciate you guys. Appreciate UC, and you guys have always been